Hello everyone, let's continue creating the dungeon crawler game. The goal for today will be to have an enemy, or the minimum thing that could constitute an enemy, so that instead of having to push this damage button to eventually get into lose state, we have an enemy that, while the party gets close enough, simply damages the party or one of the party members, probably at random. Um, so one thing before we get into the model part of that is I want to think about this how we're going to create what the enemy will look like in the world, basically. So I've been playing around a bit with RealityKit and importing 3D models, just as we imported the models that constitute the floor and the walls and the ceiling. Um, Indeed, I was able to import some skeletons from a pack that I will link down below. And I was able to import those. However, I couldn't get the animations to work. So converting from a format that is provided in the pack using Blender to a format that is supported by RealityKit, with or without reality converter and so on. Simply the animations just got lost in the way. So I'm probably doing something wrong. Um, but I have a workaround, or at least a different solution. We're going back to what we did with the asymmetric game, and we're going to use sprites. So we will have a sprite rendered from 4 different sides, and that will give us more or less the impression of an entity somewhere in the world. Actually, I kind of like that aesthetic of a mix of 3D and sprites anyway. So it's not too bad. And I think it's a nice way of showing how to integrate sprites in a RealityKit project. So for now, I'll first just show how to get a sprite in our RealityKit view. That will be all. We're not going to do anything clever with it in terms of lighting or moving it or whatever. That we do after we have an actual enemy in our game. So this will just be to show how the visual integration works of a sprite into RealityKit. So let's get started. So first off, we need a sprite. So I used my sprite exporter that I showed also in the last series to export an idle animation for this mage for 4 different sites. And for now, I'm only interested in this single frame. So I'll create a new folder for sprites, and for now it's okay to just drag this one in. I'll copy it here, and now we have it in our game project as well. And now we need a place to show it. For now, I will just render it as part of the map. This is not how it's supposed to do. Let's see if does it. Yeah, it recognize a fixed enemy. Doesn't just not go here. We will just render an enemy, and then we'll create a function called and this one will need a scene, or at least a node. Somewhere that we can add this new thing to, and then let's get started. So we need to first load the texture, and this is done as a texture resource. And this can be done using the load method named, and then we need to copy paste the name from this one. And then we need to convert this into a texture. And now we can create a material. So we'll create a sprite material. This will be an unlit material. And we'll set some properties. So we'll start by setting the color to an initial value that has a tint, white, and a texture. This is what we were interested in. This is where we can pass in a texture to give it to just show the texture on the screen. And then we'll set the blending mode to be transparent. And this will make it so that all the transparent pixels in the PNG will be transparent in the sprite as well. Otherwise, you will see a sort of a big black border around your sprite. Then we need a plane. So this is somewhere where we put project the texture on. So we need some components. We need a model component that has a mesh. I'm sorry, that has a plane. It can be 1 by 1, and as a material, we'll use a sprite material. And we need to give it a position. So for now, let's just say we have, we'll create a sprite anchor. This is the thing that will put it into the world. This will be an anchor entity, and we'll give it a world position of 1, 0, and -3. And this should place it right in front of the stair. So the idea is that the sprite will be blocking. The enemy will be blocking the stairs that lead to our treasure. And then we add the plane as a child to the sprite anchor, and then we'll have our own anchor, and we'll add the sprite anchor as a child to that one. So we should now be able to build and run this, and let's see what happens. Okay. Can't see anything. Maybe it's somewhere else. Curious. So why can't we see it? Well, let's just move it down a smidge. Hey, now we can see it. The problem was it was right dead in the center of the screen, and it's also the plane is orientated the wrong way, meaning we simply can't see it. But at least it's there. So we need a rotation to get it set correct. So we can do a plane or transform, a rotation, and we will create a new rotation with an angle. And this one is in radians. So 90 degrees would be half of pi. And the axis will rotate it around the x-axis. Okay, there it is. And in terms of visuals, this is all we'll do for now. So you can notice that it looks really flat, and we'll fix all that going forward. But at least we have a visual representation of an enemy, and I really want to go forward with creating some actual logic. So this is nice for now, so we'll omit it. And let's start thinking about a bit of logic. So let's say we'll probably have a lot of behavior for enemies, so I'll create a file called enemy tests. Let's see, what could be a first test? When given an enemy is standing right next to party, and when an update is called, party takes damage. So basically, what we're going to assume that a game calls some form of update function on our enemy every so often, and if the enemy is standing next to the party, it will attack the party or one of the party members. At least they should, and we should see it and the party as a whole take damage. So I don't think this needs to be an asynchronous function. No, it needs to be throwing. So we need a world. And that means that but we have a function to help create worlds. Or something like this. We can actually use the one that's only a single map. And the logic was these will just be, this is just an array of arrays. So let's say there's nothing on the first one, and we'll do it even, I'm sorry, we're going to make this even simpler. Are these called floors? Oh, these are called maps. Okay. We'll just say world and enemy, and we'll create a position. With 1, 0, because our party is assumed to start at 0, 0. And we'll call world.update. And then we expect that the party members' HP will be lower. We can for now assume that only the first party member gets attacked. Original HP is something like this. And then afterwards, it should be less. Okay, so there are a few things to fill in the blanks. So we need to be able to add enemies in our world. Okay, so this no longer complains now, and it needs an update function. And this means that we need to import foundation. Let's see, where are we on time? Okay, so we have a bit of time left. So there's a couple of things we need to fill in. So of course we need an enemy. So let's create a new file, like enemy, and this will be for now just a class. And let's see, our world could have when we add an enemy, we add a new enemy. And when we update, we'll say take damage. So this doesn't work as it should, but at least it will give us at least a passing test. So let's see if that's indeed the case. Okay. What I will do is I'll switch the suites around a bit. I'll say when update is called, given the party is next to the enemy, but takes damage. Because then I can create a second test. Oh, first, commit this one. So I'll create a second one that says, given the party is far away from the enemy, party does not take damage. So I'll create another world, but this time the enemy is way further away, and we'll expect them to have the same, that the HP doesn't change. Of course, this one fails because we need to make sure that we're checking to see if the enemy is indeed next to a party member. So the enemy needs position, meaning that when we add one here, we should add also the position. And now we should check if they are close by enough. If enemy position distance to party position is less than or equal to 1, then they take damage. The distance to function hasn't been created yet. Also, I'm going to call it the Manhattan distance. So this is a function we're going to add to our coordinates. And this will return an integer, and the Manhattan distance will be the absolute value of x minus other x and y minus other y. And let's see if this helps helps the tests. And now the test passes. So we have indeed added a functionality that we can update the that the update takes into account that the party is near to the to an enemy before it's able to do its damage. So we add this, and let's see if we can also get this into our game. And so what if in our content view we would say that and appear. So there should now be an enemy right in the same place where it's also visible in screen. So this doesn't change it. Oh, and we should be calling update, I guess. Okay, so let's see what happens if, oh, look at how fast it's attacking. It's now currently damaging every update, which is a bit much, and it's only doing one player. So we can keep this up, but notice while we step away, hey, it's no longer damaging. So seems to be working. So the next step would be to add at least some form of cooldown to make this a bit less crazy. If the party next to enemy and cooldown is still in effect, party not take damage. So we will assign world. We can use put the enemy right next to the player. We'll attack once. That's the first update. Then we'll determine the HP, and then we will say update at the cooldown. Let's assume that it's 1 second for now. So we'll add half a second, so we're still in the cooldown. And now it should no longer attack. So let's run this test. Let's go to our enemy. And now when we attack, yeah, this is fine. Let's say it attacks. If, oh, and then needs a time. If time is greater than or equal to cooldown expires, then we can attack. So then we can do party member to take damage 1 and set the cooldown to time, including the new cooldown. Otherwise, we don't do anything. And now we need to call this one from our world. So instead of doing damaging here, we can say enemy.attack party members complet at time. Let's see if this helps. Okay, now the test passes. Let's see, what else? Let's see what this looks like in our game. So we can come closer. Now we can see we're taking damage every second instead of every frame update. So this works. I want to reorganize this test a bit. So we have when updating scrolling at read given a player is next to the enemy, because this is on a couple of things. Okay. What I would like to get away from is the way these worlds are created. So adding the enemies this way as a sort of second step in the world doesn't really sit well with me. I would expect that if you look at the here we're creating a map. Ideally, we should be able to just say, okay, I want an enemy here, and I want an item there, and whatever, and not having to basically hack them on later on here. Also notice that enemies are still are not floor dependent at this time. So what I'll do is I'll go into attack that and make a couple of things. So clean up the initializer for world.